Welcome to Hacking Next Gen ATMs from Capture to Cashout with Weston Hecker in South Seas ABE. Before we begin, a few brief notes. Stop by the business hall located in Bayside AB. The Black Hat Arsenal is on in the Palm Foyer on level 3. And of course the Arsenal reception is at 5 p.m. If you haven't picked up your merchandise, today is your last chance to visit the Black Hat Swag and Bookstore. Visit the Kali Lab in Mandalay Bay A. And finally, thank you for putting your phones on vibrate. Makes it easier for the rest of us to ignore it. And with that, please welcome Weston Hecker.
Hello, can everyone hear me pretty good? Awesome, pretty good, okay. So my name is Weston Hecker, and I'm going to be going over hacking next-gen ATMs from Capture to Cashout. I work for Rapid7, do pen testing for a living, do a lot of security research on the side. I've done a couple talks in the past at DEF CON that have, they've been pretty good talks. And so I'm a senior security engineer, like I said, pen testing, I do tons of speaking, done DEF CON the last few years, Hope, Takedown Con. It's really good events, really good people in the community, just love getting out and meeting people. So. And other projects, I have some mitigation for attacks on PSAPs and things like that. So for 911 centers, it's something I'm working with some government facilities to actually stop people from doing telephone denial of service. And do a lot of reverse engineering of malware, ransomware, hacking cars, point of sale systems, pretty much anything. So let's see here. Yeah, safety first. So when you're driving an ATM across the United States with a ton of shimming and skimming devices, it's something that I took a little bit more due diligence because I didn't want everything to disappear as soon as I landed at the valet booth. So it's something where I actually pushed the firmware to the devices the night before my talk. So like even leaving them unattended in hotel rooms kind of scared me. So that's something where I took a little bit of a extra step in making sure that none of these fall into the wrong hands. I did a lot of this research and all this research just like give the vendors a little bit more time to be able to fix some of the stuff before it becomes widely used. So. And yeah, what's this talk going to be about? It's going to be on the EMV protocol. I'm going to do some Carter systems and automating the cash out. So the actual automation in the cash out was to kind of go with the DEF CON theme this year, which is Rise of the Machines. This setup that I'm going to be going through, this would have worked. There's a singular version of it also that is literally just a cell phone and a card. So it's not something where somebody has to put something on like this on an ATM machine. This is just literally for automation purposes. And when you do research by yourself, sometimes you don't have anybody to help on stage. So now I have a couple Arduinos and a Raspberry Pi helping me. So, and yeah, I'm going to go over the actual attacks on the EMV, the actual standard, relay attacks on physical cards. Some of the point of sale ones have gone over in the past. This will be a little bit more in depth on some of the actual ATM surface. And I'm going to go and tour the new methods and distribution of how I would see the bad guys actually, in a couple years being able, because right now they're going for the low-hanging fruit, which is the mag strip data. And that's something where I wanted to know what direction they were going to be going in. For some of this stuff once the liability shifts happen, and there's the big shifts coming for the actual ATM systems in 2017 and the gas pump systems. So it's something where I wanted to take a look at once the low-hanging fruit's gone, how are these guys going to shift their actual attack tactics. And I'm going to look at the actual ATM communication backend, the financial institution portion. Making a credit processor and actual banking backend from scratch is not as easy as it sounds. So especially for demonstration purposes. So it's something where I'm going to actually go over a little bit of that also. So, and introducing La-Cara, that's going to be the actual automated cash out method. So the demo, it's about 400 hours of research, so stuck a lot of time into this, and a lot of it was reading of 1,400-page manuals. So, and yeah, so what is EMV? It was developed in France in the early 80s, Europay MasterCard Visa. It's known as chip and choice or chip and pin in the United States. That's the actual EMV code is the actual managed body, and replaces the mag strip cards, or at least it will change the point of sale limits. Mag strips, when everything is fully EMV implemented and chip and pin implemented, it'll most likely do what they did in Europe. It'll go down to a $40 transaction. And like I said, there's several liability shifts that are forcing people to have expensive risk if they don't actually switch everything by then. So. And yeah, how I actually started out researching some of this stuff was I was actually going around, I have a couple scripts that went around on Carter firms and were collecting PAN information and BIN numbers to see where a lot of the credit cards are being collected from. And that's just not something where I was actually interacting with their databases or anything. It was literally just going on the pages, filtering these Carter sites by the actual area codes and seeing which banks were breached in which areas. And it's kind of some of the research that some of the other guys do, except for I took a little bit extra step and kind of automated a majority of it. So, and yeah, so basically I noticed that they were having a lot of lists for sale that like some of them included some of the flagging data for some of the actual point of sale systems and the actual the flagging system on the EMV protocols. It tells it if this can be used for cash and or if you can use it at an ATM machine, if it's only for gas, only for food. So some of those other systems, they're actually doing a lot of research. So as soon as a card falls into the wrong hands, they're pulling some of this information off most likely and actually putting it into these databases and either sharing it with their cohorts. So, but yeah, so I started out on a bunch of Russian Carter web pages, and yeah, that was kind of what led to some of the research and me purchasing an ATM. So, and this is the current, the method that the bad guys go online. They'll actually purchase static credit card data, track 1, 2, and 3 data. Most of the times, that's just the interesting track 2 information. So, this is something where they can literally buy, X amount for $12.50. The bad guys, they'll buy, a breached credit card number. So that's something where, it's delivered, they make the physical card, and they can't go from that point. So, and this is kind of what I envisioned as the Carter site of the future. And this is kind of what the bad guys, because it's one of the things where they're not going to be able to sell static data for the most part, and if it will, it'll be used for online transactions and things like that. So that's something where this is what I envisioned that the bad guys would be changing a lot of this to. And this is strictly for research purposes. It's not a functional Carter site. It was just kind of if with the actual fraud backend or the actual simulated fraud backend, like the system for actually passing the credit card data into this ATM machine, that was something that is also built. And it does all these EMV transactions in live time. So, and this is kind of what I envisioned as far as what the bad guys would do. So, and yeah, so there's a couple of difference. They have to actually select which region of the United States they're in, if it's going to be an automated method, what the actual cash out device is. So there's a couple, things that they would have to actually set up. In addition, it's not just simply buying static data anymore. They're actually basically purchasing a VPN tunnel to a fraud network is what the method that I see the bad guys moving towards. And it's something that, if there's several ways that people can actually stop this stuff if they take a little bit look of what the extent that the bad guys would eventually go to. And yeah, so there's, you have to actually enter a couple passwords. Some of them give you actually DES keys for connecting to the fraud network, things like that. So, or not the fraud network, but the actual delivery system. And it's all for demonstration purposes at this point. So. And yeah, so here's basically how it works. You're actually purchasing time on a fraud, on this back-end system. So it's something, your transaction, as you can see right there, or the bad guy's transaction, that's actually in a blockchain of events. So they're basically going to get their transaction data at a specific time. That's when the bad guy is at the cash out machine. So that's something we're going through this. You can look and you can see their time block. All the other ones are also distributed. It sends all the information in the blockchain. Some of the information entered on the other page, such as the delimiting characters that people will need for some of the tunnel information. Like that will be in earlier transactions. So the info type and quality. So pretty much it goes through all this information. That's what your actual packets that will be included in the blockchain will include. That's a lot of the information that will be included. So basically all of the shimmed devices that are working out in the world, from the bad guys, say they've skimmed like 300 point of sale systems, it's actually going to be passing off into this blockchain. And then whoever purchases those time slots will basically get a VPN tunnel, a private session with that shimmed device and have that information passed off. So yeah, so here's like I was saying, some of the tunnel information. This is it. This breaks it down in the timeline. It's kind of like a Gantt type situation. So it gives you the information type, the 5 digits for the time frame, and it's going to go into a lot of the tunnel IDs, and it's also going to send the PIN information when it's entered on the next transaction that happened on the point of sale system. So that's something where the actual shimmer that's in the device not only is impersonating the cash out machine, but it's also collecting a lot of the same data because a lot of it's on unencrypted channels, or there's classic methods, which I'll go into in a little bit here. So. And it'll also let you know the limits of your of the transactions that the bad guys are purchasing. So, and yeah, so here's like I was saying, on that blockchain, there's going to be padding data, which is like empty slots or unused slots, or even other people's transactions, and that basically will give you the connection info, so you can initiate the GRE tunnel before your actual cash out time or the bad guy's cash out time. So that's something where the transaction, as soon as it comes along, it's able to communicate, it validates the keys of the actual fraud device, and then it passes it off on the network. So this is something where I don't believe that people have been able to monetize something that, this is like the system. It's like right now they have the low-hanging fruit, the mag strips. They're not going to move away from that stuff. So until, down the road when everything is speaking EMV. So. And yeah, so what kind of stuff can be passed off to these bad networks for the bad guys to use? So static mag card data, obviously. So if mag card data, well, there'll still be a market for it as far as some of the research that people have done. It's definitely something that'll be around for a little bit. And the actual EMV, some of the dynamic and the actual combined authentication methods, RFID, which is not the tokenized like Apple Pay stuff, it's the actual RFID enabled cards. So that's something where a lot of this information can be passed off into that real-time network using the blockchain method. So it rejects the cards with the flags not set for the ATM. So say, for example, you have a business card that is literally only used for fuel. It won't intercept those kind of transactions. And there's actual flag information that will, the initial communication process, it'll let it know that those aren't going to be available for use. So aside from the card being passed off, the bad guys will also be able to pass off PIN numbers. Some of them will be able to actually just switch it to that there was a signature sign, things like that. So there's tons of actual EMV attacks that people have passed off in the past. So the number of assumed liability or assumed ATM limits. So that was one of the things I saw the bad guys were collecting. So based on bank identification numbers, which are the first 6 digit on the cards, they can assume that that's a more prestigious bank. They will have a $3,000 ATM limit or a $500 ATM limit. And they can actually proof some of that once they get more transactions going. So. And here's a little bit of a diagram. So you got the 4 bad devices, the shim devices. This would be more of the real world. This is actually how I started out my demo. Is I had 4 EMV enabled devices or chip and pin devices that were enabled, and they were passing to my simple cash out card hooked to a phone. And that's something where I was starting to see how it actually communicates on the actual network. So basically, as the initiation of the actual transaction starts, it actually passes them off to the card remotely. So and that's something where there is not a really good way to load balance this, aside from you can't actually take data and use it later. It's literally has to be passed off in live time. So that's one of the methods where as soon as the initiation is started, it'll actually pass it through to the ATM. So and that's the actual cash out ATM. So you can insert as many shim devices as you want. So. And here's the most likely method that the card data would be sold, like the whole carding system. That's kind of what one of them, there was like 3 talks inside of one talk here. So like the entire fraud, like the fraud backend, the extents that the guys will actually go to, the bad guys, that's something where a small carder site, if they have unused transactions, like the system that I built, it was so they can have leased gear. Like right now they have mules that go out and shim these devices. There are people that aren't, they're just one part in the cog. And some of those systems, like they'll have the leased gear, so they'll send gear out, and then it'll actually feed into the actual carder site. They have mules, employees. There's lots of ways. Independent small breaches. There's like smaller carder sites that they can actually, the smaller carder sites will feed to their larger carder sites if they have unused transactions. So if there's unused transactions, you can actually pass them off to other blockchains. So, and it is, that's the way I envisioned it at least. So. And yeah, so this is basically, it holds for round 2 on the actual Shimmed device. So there's a point of sale device that's going on here, and after the initiation information is passed off, pretty much all the request information is passed off. So all this is going on inside of the ATM. It's doing a $1,500 point of sale, or not point of sale, an ATM transaction. So the PIN information was entered at a later time. So, and that's what's going to be going through in the demo actually, is it's going to be passing off not only the actual card information to the ATM slot. So it's going to be fully simulating and knocking off the actual card that is not in the ATM machine. It's going to be impersonating actual cards, and then it's going to be sending and entering the PIN information on the actual automated cash out. So this gives you a little bit of an idea of how it would affect the actual point of sale terminal. Worst case scenario on the ones that I demoed, I had to enter the PIN number twice. So, and that's some of the stuff we're at the research stage of it. So. And yeah, like I was saying, like they're able to feed into the main carder sites from a lot of the smaller carder sites, or there's other ways that, that was one of the biggest things, is that distribution system, all blockchain based. So it's where people are kicking transactions out. So, And yeah, this is not cloning the card. That's one of the big things. Everybody else, for the most part, there's about a 1-minute window, where some of this information is valid. It has to be used before other information is used. So there's a lot of things that to take away from it is that it's not actually cloning the card. That would be very, very expensive to actually even remotely start to do that kind of thing. And so the 4 stages of the EMV transactions are captured and released into the tunnel, speaking to an ATM. So it's literally an EMV relay attack for the most part. And the cash out device, pretty much sends the exact same data as the shim device. So, and it's going to be told its tunnel transaction. The PIN information will also be sent into the same information chain. So once the initiation of the communication is actually made. So the point of sale limit, Shimmed will not count against the actual ATM daily limit. So as everybody knows, like you have a point of sale limit on your card, and then you also have an ATM limit. And so that's one of the things that the bad guys are going to go for non-ATM machines. These things are brick houses. They have tons of foreign object detection. They have the most advanced features for detecting that. So I think some of the actual point of sale terminals are going to be what people are going for, and especially gas pumps. Something that's unattended for 12 hours out of the day is a pretty good attack surface for the bad guys to go after. So, yeah, shimmer versus skimmer. There's been tons of research, and people have found a lot of the shimmers used in the wild. A lot of them were actually used for downgrade attacks or improperly implemented EMV backends. So it's something that, so a lot of them that have been found in the wild have been, I've heard of even ones turning up that have serial numbers on them. So these things are being professionally produced, and it's definitely a surface that the bad guys are going to spare no expense on. So, and one of the actual shimmers that I built for my demonstration purposes, aside from being able to actually steal the contact information, because it's getting in between the actual card, it's also able to impersonate some of the initial transactions. So it's basically extending the slot of that ATM machine. So that's one of the things as I saw as the biggest things that people are going to go after is the point of sale systems. So, and as far as found out in the wild, a lot of the ones that have been found are modified parts. Like a lot of the ones that I built were modified cell phone hacking tools, things like that. Things that are readily available. They don't have any illegalness to them. It's just literally, 3 parts together makes some of the devices that are seen. So, and what is the cash out device? It's actually an Arduino, several servos. There's like 8 or 9 servos. And then, so basically, this is what the initial setup is. There's the actual single system, which would just be a cell phone, and then an actual EMV card that is able to impersonate EMV actual communication. And it basically, some of the chip and pin works on 6 and 8 pin. So, but the Arduinos are basically a microcontroller that you can send impulses. So instead of flashing an LED when a 1 is entered, it's going to take that information to turn this servo motor to push 1. So basically inside of the actual La-Cara cash-out mechanism, it actually has a bunch of servos that will automatically enter the pin numbers, and it will automatically put in the actual EMV card data. So, and like I was saying, in the single standalone version of it, it'll actually show the pin on the LG or the actual phone or whatever the device, the Android device the person has. So, but there's tons of small parts. Person, as you can see on the left or on the right there, you could actually do 1356, which is the near field communication or the RFID based cards. This one is not equipped to do RFID or inject credit cards using the actual EM field, like the Samicam car's mag spoofer. So you could actually inject credit card data. So you can do the bad guys can actually do tons of information. It's just speaking to the magnetic heads inside of the actual ATM machine by creating a huge EM field. So, and introducing La-Cara. So why would somebody want to cash out a method like this? And people are untrustable. This is actually from that $45 million breach that happened a while ago. It was in the news. These gentlemen put, they put a picture of themselves with what looks to be about $60,000 that was most likely in an ATM about an hour ago. So, and the actual cash out crews, a lot of people brag about it. Social media has covered several times where everything was going good, like it was a advanced attack, and then it came down to a couple guys in puffy coats inside of a Hummer H2 kind of situation where, they were tweeting about it or things like that. So, and they're basically busted and they rat out their accomplices. So the machines don't usually have Twitter accounts. That was one of the biggest things. And one of the greatest parts was the actual DEF CON theme this year, which was the rise of the machines. And I've always wanted to me and a coworker had spoke about this kind of thing. It would be, we were originally conceiving a drone that could fly up and do an ATM transaction, and it's not as easy as it sounds, but so that's something where I was like, I want to do the themed version of it. So yeah, I started doing research on some of the servo automation, and yeah, it works pretty awesome. And you guys will get to see that in the demo here in a little bit. So. And yeah, La-Cara actually does have a Twitter feed. I was going to broadcast some of the card traffic. Yeah, so, but yeah, normally ATMs don't have a Twitter account. So, and they're all simulated networks, backends and stuff. So that's not the actual problem with this, but yeah. So that smiling guy inside the ATM right there, that was this picture was taken pretty recent after I actually bought the ATM machine. And I'm going to go into what went into actually making the buck and plug mold for the actual cash out fascia. I imagine that the actual bad guys would 3D print it. It would take a pretty large 3D printer, or at least 3 parts, to do this together. So, and here's the evolution of La-Cara. So you basically start out with your stock ATM, which these things are very simply purchased on, you know, any third-party web page. A lot of the newer devices, they have tons of paperwork that go with them. This one was paid, you know, paid cash, just bought it kind of situation. So. Yeah, and as far as that, you just cover it with tape, and but you basically make a plug, and then you shave the foam down, and then you actually can lay fiberglass over it, and yeah. And the Swiss Army knife. So yeah, this can the version that person that obviously, you know, if somebody was to automate this fully to accept any kind of the transactions that were coming through, this would basically be they would add, like I was saying, some of the mag spoofer functionality, and then the actual yeah, actual cash out mechanisms. So, and here's a little bit of when I was actually training my Arduinos in their early stage of the actual button clicking. Yeah, it was really, really cool just to see it entering pin numbers. You know, from going to, you know, just flashing LEDs for the numbers to actually, you know, moving servo motors. It was a really cool process, and I enjoyed doing it immensely. So, and yeah, building your own banking backend. That's something that obviously, you know, you couldn't get a lot of access to banking backends. Those things are very, very locked down. It's something where people are very secretive about them. There are best standards and best practices, and there's lots of methodologies for actual bank processing. So that's one of the things is, so this actual ATM does have some of the fraud mechanisms built into it. It has its DES keys. It's now talking to a gateway processor that's talking to 150,000 simulated bank accounts. And right now, actually since the 27th of last month, there have been EMV transactions going on nonstop, so I can monitor actual transaction data and see what is a deviation from that normalness. So each of the accounts are signed with banking keys. So all the my actual card stock is all signed with keys. This is exactly how they have it set up for the actual point of sale systems now, and we'll be eventually bringing them into the actual banking industry, or the actual ATM industry. Yeah, so the skimmer generation is also signed with some of the Field 55 training information, which is where a lot of the fraud flags and the risk is now analyzed, and that's one of the banking one of the systems that I was actually working on to actually see how, and that's some of the same methods that some of the bad guys and the good guys actually do too, is they have these, they can actually share, you know, information like, hey, we had this ATM hit. Now they're going to put inside of that fraud information and those analytics, they can actually stop future attacks when they share some of the same characteristics. So, and yeah, so here's the actual normal EMV transaction. So it touches the card, goes to the point of sale system, they do their initial talk, they talk to an acquirer or a gateway processor, and then it goes back to the bank issuer. Then there's a couple cycles in this. There's a lot greater explanations online, and it is 1,438 pages, over 4 books. So yeah, it's a lot of reading to fully understand EMV, but I think this should get the gist, because it actually starts out at the card, goes to the point of sale system, goes through the acquirer and to the bank issuer, validates that the money's there and that the risk is good. So basically, the part that this is happening is actual step 2. As you can see off to the right, there's an entire different transaction going on, allowing the original point of sale system to initiate the actual reason that person stuck that card in the machine. So off to the side, some of the receipt information, depending how they have it set up, would not, you know, actually get sent to the original point of sale terminal, or it would get sent back to the original point of sale terminal because it doesn't actually go through the same gateway that the ATM is doing. So there's a little bit of tweaking depending on how people have their integrations, but a lot of people are moving towards the exact same integration of the actual protocol and standards. So as you can see, to get the biggest step away from this slide is actually that there is an entire transaction going off inside of an ATM, while the point of sale system is literally just taking as long as some of the transactions. 15 seconds seems like an eternity when you just checked out at a gas station. So, and yeah, the past and present. So we have a chip. How about the pin? That's one of the biggest things too. It's like, hey, Weston, that's great. You can get that. What automated methods do people have for capturing pins? And actually, one of them was an original method that I haven't seen used, and it actually uses security features of ATMs against themselves. So, and the methods of the past and present. So there's the camera pin model. So that's a pretty simple way. The pin overlays, that could be directly translated automatically. That would be, keypad 1 is pushed here, translated over to the other side. So unencrypted pin traces, so supply chain attacks or actual contacts, that would involve modification. Some of the actual pin numbers are done in clear, not on a lot of the newer card stock moving into the United States on the actual cards. So, and yeah, the camera method. And this is the method that I came up with. It was actually a radar-based pin system that uses the foreign object detection, so that's pulsing these radio waves, these very, very powerful radio waves, detecting if there's anything metallic on the actual device. So what's the first thing I did is I actually put very little pieces of metallic metal. So I basically put a bunch of iron oxide after I sprayed the keypad on this device here. This is for the demonstration purposes. So I sprayed the actual keypad with 3M glue and just basically sprinkled iron oxide, so little pieces of metal. And actually, as you touch each of the keys, it creates a different ground field, and you can actually watch it in a waterfall. And based off those little peaks, you can actually throw that into OpenCV. And I had a reader for some of the peaks, and it was pretty accurate. It was a lot more accurate than I thought it would be. And our initial concept of it was actually, I used a little smaller radio, but that one didn't have as big of an output for as far as what I needed. So that's something where these devices would be placed outside the actual range of the foreign object detection, which is literally just looking for the keypad and most of the times the actual sensors on the ATMs. So this is basically a pin radar system. So each time their finger pushes it, yeah, it literally tells them which key it does. So, and when you actually, after the iron oxide's all done, I had to train it because I randomly sprinkled little pieces of metal. So after one training, it was able to pick up the actual key information that was picked up on the basic radar. So, and probing the networks and card settings, estimating the amounts off of the bin numbers. So like I was saying, more prestigious banks obviously have more money. And that's one of the big things that the guys are going after. They've used it in their current, the bad guys have actually used it in their current infrastructure for as far as their carding sites go. So that's something where, this card is well known to have a $20,000 limit. So they're going to sell it for $145 compared to the $12.50 of So it's something where, what is the BIN, the bank identification number? Like I said, that's going to be the first 6 digits on the card. The point of sale versus ATM limits, that's what I'm saying. Like that's one of the biggest things that the bad guys will take advantage of. And that's one of the biggest takeaways from this. It was like, hey, have a separate PIN for actual point of sale transactions versus ATM limits. There are a couple providers that are actually doing that kind of stuff in Germany, and I give them a hat off because they're taking that due diligence and seeing what the bad guys are doing before they're actually going to do it. So, and some of the Japanese and okay, Weston, what kind of ATM has $50,000 in it? There was actually, I think it was reported in between Japan and China, there was like 150 separate ones that I found that have those kind of things, dispense hundreds. So, and Dubai, there's ones that even dispense gold. So. Yeah, so it's pretty crazy amount of ATMs that actually have this kind of money in them. So, and yeah, so the shimmed point of sale systems, that's going to be where they're going to be the favorites for some of the bad guys, is what I'm guessing. And that's why I was thinking, in this actual field, some of the information that people are looking into, it'd be nice to have preemptive ways to block this kind of stuff. Habits of putting an EMV in early. Like I know a bunch of point of sale terminals out there. They have the little piece of paper that says "Do not use" right now. But pretty soon we're going to be used to waiting with our card inside there for 34 or 40 seconds in some cases. So, yeah, and it, like I said, it takes from the actual point of sale limit, you're taking off the ATM limit, not the actual in-store transaction amount. So, and ATM cash out is uninterrupted. So, and shimming the bank, the front desk, gas pumps, some of the anything that has an EMV contacts or chip and pin contacts would be potential a target for this. So, And yeah, like I was saying, the first shift for ATMs and gas pumps is coming in 2017, the last I checked. So, and that's going to be one of the biggest ones. That's one of the ones right now, like every time I fill with gas, I'm pulling on the front of that thing. So, but yeah, I'm going to kick off the demo here. I just wanted to give a shout out to my wife, my kids, Jesus. Barnaby Jack is the master of jackpotting ATMs. I just wanted to give him a shout out. He made it a lot easier for people to do this kind of research. I just wanted to give him a thanks. A ton of Sammy Kamkar's research with Mag Spoofer. All the previous people that have done point of sale demos, some of the Cambridge team, they all did very good research. A lot of the people that helped with Fat Pat, Iconic, and Total Downer. Total Downer helped me a lot with, those are obviously their handles, so, but it did help me a lot with it. So, and random people in chat rooms and forums. So I'm going to kick this off here. There we go. So it's actually intercepted its first transaction. I had to get it to a state that it knows, because this, to say it's an unmodified ATM, I did upgrade it to EMV. So, oh shit, sorry. To officially jackpot ATMs, you have to open the front fascia on them here. There we go. Sorry about that. So yeah, basically, it handed off its first EMV transaction. It picked up the actual information. I had to get it to a known state because I don't have anything running into the PCBs, so I can't tell what state the actual screens are on. And if you sound what sounds like rattlesnakes, is actually a bunch of servos entering the PIN numbers, the dollar amounts, not asking for a receipt. So, yeah. I'm going to open up to questions if anybody has any questions. And so basically, each one of these transactions, it's passing off the card data. It's receiving a PIN number, waiting for the prompting, enters the PIN number, and the actual transaction goes off. So, yes. And if you have any questions, please step up to the microphone. So.